Ever felt that math class was just a bunch of abstract numbers and weird symbols with no connection to the real world? Like, when are we ever going to use calculus to buy groceries? Well, what if I told you that math is everywhere, working silently behind the scenes, shaping our world in ways you've never imagined? From your morning coffee to your favorite blockbuster movie, math is the unsung hero. Today, we're going to uncover the secret life of mathematics and explore some of its most surprising applications. Stick around, because you're about to see numbers in a whole new light. Let's start with something we all love: movies. Ever wondered how those incredible animated films from studios like Pixar and Disney look so realistic? The secret ingredient is math. Specifically, a branch called linear algebra. Think about Buzz Lightyear or Elsa. Every character is essentially a complex digital puppet made of thousands, sometimes millions of tiny polygons called a mesh, to make them move, talk, and express emotions. Animators use matrices, those grids of numbers you might remember. These matrices rotate, scale, and translate the character in 3D space. When Elsa belts out "Let It Go," it's linear algebra that's calculating how her hair flows in the wind and how the light reflects off her icy dress. And it's not just animation. The stunning special effects in superhero movies, that's all powered by complex equations, particularly differential equations, which model things like explosions, water, and smoke. So next time you're captivated by a movie's visual magic, remember to thank an algorithm. Okay, let's move from the screen to your pocket. Your smartphone is a powerhouse of mathematical genius. How does GPS know your exact location and the fastest route to your destination? It's a beautiful application of geometry and algebra. Your phone receives signals from multiple satellites orbiting the Earth. Each signal tells your phone how far it is from that specific satellite. Imagine drawing a giant sphere around each satellite, with the radius being your distance to it. The point where all these spheres intersect is your location on Earth. This is a modern-day application of a classic math problem called trilateration. And what about finding the quickest route? That's where graph theory comes in. Apps like Google Maps treat the road network as a massive graph, with intersections as nodes and roads as edges. Algorithms like Dijkstra's algorithm then calculate the shortest path from point A to point B, factoring in real-time traffic data, which itself is a statistical model. It's an incredible symphony of calculations happening every second just to get you to your favorite pizza place on time. Now, let's talk about something vital to our modern world: security. Every time you shop online, send a private message, or log into your bank account, you're relying on a branch of mathematics called cryptography. The backbone of modern internet security is something called public key cryptography, and it's built on a fascinating area of number theory involving prime numbers. Here's the gist. Your computer generates two keys, a public key and a private key. They are mathematically linked, but it's practically impossible to figure out the private key from the public one. Why? Because it involves factoring a huge number into its two prime components. For a computer, multiplying two massive prime numbers is easy, but doing the reverse, finding those original primes from the product, is incredibly difficult and would take even the fastest supercomputers thousands of years to crack. So when you send your credit card information, it's encrypted with the website's public key, and only they can decrypt it with their secret private key. It's all thanks to the simple, yet profound properties of prime numbers. Let's switch gears to something more organic: nature. You might not think of a sunflower or a seashell as a mathematical object, but they are full of beautiful numerical patterns. Have you ever noticed the spiral patterns in the center of a sunflower? If you count the spirals going clockwise and counterclockwise, you'll often find two consecutive numbers from the Fibonacci sequence. That's the sequence where each number is the sum of the two preceding ones: 1, 1, 2, 3, 5, 8, 13, and so on. This isn't a coincidence. This arrangement, known as Fermat's spiral, is the most efficient way for the plant to pack its seeds, ensuring each one gets maximum exposure to sunlight and nutrients. You can find the same sequence in pine cones, pineapples, and the branching of trees. Then there's the golden ratio, approximately 1.618, which is closely related to the Fibonacci sequence. This ratio appears in the spiral of a nautilus shell, the proportions of the human body, and even the structure of galaxies. Math provides the blueprint for the elegance and efficiency we see all around us in the natural world. How about the world of sports? Coaches and athletes are increasingly using math and statistics, a field known as sports analytics, to gain a competitive edge. In baseball, it's called sabermetrics. Instead of just looking at traditional stats like batting average, analysts use complex algorithms to determine a player's true value. They calculate things like wins above replacement, which estimates how many more wins a player gives their team compared to an average replacement player. This helps teams make smarter decisions about who to draft and sign. In basketball, teams use player tracking technology to analyze every movement on the court. They use geometry and statistical models to figure out the most efficient shots, which is why you see so many more three-pointers and layups these days. The mid-range jumper has been mathematically proven to be a low-percentage shot. Even in soccer, data analysts track player positioning and passing networks to identify weaknesses in the opponent's formation. It's no longer just about talent, it's about strategy backed by data. And what about the future? The role of mathematics is only going to grow, especially with the rise of artificial intelligence and machine learning. At its core, AI is built on math. Neural networks, the brains behind things like ChatGPT and self-driving cars, are essentially complex webs of mathematical functions. They learn by adjusting the values within these functions over and over again, a process called optimization, which is heavily based on calculus. Every time you see an AI generate a stunning image or write a coherent paragraph, it's solving a massive mathematical problem. Data science, another booming field, is fundamentally applied statistics and linear algebra. It's what allows companies like Netflix to recommend movies you love and Amazon to suggest products you might need. They analyze vast datasets of user behavior, find patterns using mathematical algorithms, and make predictions. The future of technology, medicine, finance, and nearly every other industry will be driven by our ability to understand and apply sophisticated mathematical models. So, the next time you hear someone say math is useless, you can tell them that without it. We wouldn't have our favorite movies, our smartphones, a secure internet, or a deep understanding of the universe. Math isn't just a subject in a textbook. It's a universal language that describes the world, a powerful tool that solves real-world problems, and a source of hidden beauty and order. It's the invisible architecture of our modern lives. The next time you solve a puzzle, follow a recipe, or even just admire a flower, take a moment to appreciate the silent, powerful numbers at work. The world is full of mathematical wonders, just waiting to be discovered. Thanks for watching, and if you enjoyed this journey into the world of numbers, don't forget to like, share, and subscribe for more content that makes you see the world differently. See you in the next one.